Okay, let's go on with the next example. And this example is also a little bit different. It's a little bit more complicated. Now, every time you see brackets, this brackets actually means that whatever number you have outside of the bracket applies to everything inside of the bracket. So for example, let's work here. If you have this OH and a 2, it means this 2 applies to the oxygen and it applies to the hydrogen. So it applies to both of them. So this 2 means you're going to have 2 oxygens and 2 hydrogens. For example, if I had a OH and I put a 4 here, it means this 4 goes to the oxygen and it also goes to the hydrogen. So you have 4 hydrogens and 4 oxygens. So whatever you have outside of the bracket applies to everything inside of the bracket. Okay, so just keep that in mind when we have this bracket here. This 2 here outside of this OH will apply to both the oxygen and the hydrogen. Okay. Now remember, we cannot change subscripts, but we can only change coefficients, and we have to start with every other element and leave oxygen and hydrogen for last. So let's start here with zinc. Right, so can you see here we have 1 zinc on this side, 1 zinc on that side, so the zinc is fine. Right, so zinc is okay. Let's move on now to chlorine. On this side we have 1 chlorine. On this side we have zinc Cl2, so we have 2 chlorines. So we need to make this side equal to 2. So how can we do that? We're going to put a coefficient of 2 in front of here. If I put a coefficient here in front of HCl, it means this 2 now gives you 2 chlorines. So now I have 2 chlorines this side, 2 chlorines this side, so chlorine is fine. Now we can move on to hydrogen and oxygen. Let's start with hydrogen first. Okay, now can you see here we have hydrogen in the OH, and remember I told you this 2 applies to the hydrogen and it applies to the oxygen. So this 2 means I have 2 hydrogens here. But now on this side, which is the reactant side, I also have 2 from HCl. So altogether I have 2 hydrogens from here, 2 hydrogens from here, which gives me altogether 4 hydrogens. Now on this side I have H2O, and here I only have 2 hydrogens. So to make this also 4 hydrogens, like on this side, I'm going to put a 2 in front of this. So now 2 times 2 will give me 4 hydrogens. So now the hydrogens are 4 on this side, 4 on this side, so hydrogen is fine. Let's move on to oxygen. Now again, oxygen here, it's in brackets, which means this subscript 2 applies to the oxygen also. So here I have 2 oxygens, and here I have H2O, and because the 2 coefficient is in front of water, it means it applies to the oxygen also. So I have 2 oxygens on this side, 2 oxygen on this side, so this equation is totally balanced. All I had to do is put a 2 in front of HCl, put a 2 in front of water. Okay, right, now let's carry on. So here we have SO2 plus O2 giving you SO3. Now just keep in mind, here we have 2 places where we have oxygen. We have it here in the SO2 and we have it in the oxygen. Right, so we need to make left hand side equal to right hand side. Now let's start with the sulfur. Sulfur, you have 1 on this side and 1 on this side. So sulfur is fine. We don't need to change anything. But let's look at the oxygen. Oxygen, we have 2 from here and 2 from here, which means we have 4 oxygen, and on this side we have a 3 here, which means we have 3 oxygen. Now this is similar to that other example where you have different numbers and there's no way you can change these numbers into each other. So if you have 4 and you have 3 oxygens, you can't change a 3 into a 4. So what you're going to do is you're going to take the 4 and the 3 and you're going to multiply it to each other. So you're going to say 4 times 3, and that will give you 12. So what you need to do is make both sides equal to 12. So we're going to make this side equal to 12 and this side equal to 12. Okay, and the way you're going to do that is if you have a 3, you're going to multiply it by 4, and if you have a 4, you're going to multiply it by 3. Now let's start with this side here. Can you see we have 3 oxygens because the subscript is 3? Which means if we want to make it into 12, we have to say 3 times 4, and that will give you 12. So if I put a 4 in front of this here, I will get 4 times 3, which will give me 12 oxygens. Okay, right. So this side I have 12 oxygens. Now, because I put this coefficient of 4 in front of SO3, this 4, it applies both to the sulfur and to the oxygen, which means now I have changed sulfur into 4 also. So because I have 4 sulfurs on this side now, I only have 1 on this side. I have to make this side also 4 so we can equal to this side. So what am I going to do? I am going to change this to a 4. So because I put a 4 in front of this sulfur, now I have 4 sulfurs here, 4 sulfurs here. But at the same time of doing that, this 4 also now applies to the oxygen also. So now I've changed also the amount of oxygens I have. So because I put a 4 in front of here and you have a 2 already, it's going to become 4 times 2, which is 8 oxygens. So now I have 8 oxygens here. And here I have 2 oxygens. So if I add them together, it will give me 8 plus 2, which will give me 10 oxygens. Okay, and remember we said we need to make it equal to 12. So we need to make this side to 12 and we have 10. Now, if you look at it, can you see that I have oxygen on both sides? And on this side, I have sulfur. So if I change a number here, if I change this 4, it means the sulfur is going to change and then everything will change again. So instead of changing this number, I am going to put the coefficient in front of this because here oxygen is alone. So whatever I change, it will only apply to oxygen. Now, if I put a number in front of this, it will be multiplied by this number, and when I add this to this 8 oxygens, it must give me 12. So if I have a 2 here and I multiply this by 2, it will be 2 times 2, which will give you 4 oxygens, and on this side I have 4 times 2, which is 8. So 8 plus 4 will give you 12, and this side I also have 12 oxygens. So now the equation is balanced. Both sides you have 4 sulfurs and both sides you have 12 oxygens. Okay, so can you see this one is a bit more tricky? Right, let's do another difficult one. Now, let's look at this one. You have PCl5 plus H2O giving you H3PO4 plus HCl. Now, remember we said we're not touching subscripts, we're only changing coefficients, and we're leaving hydrogen and oxygen for last. So we're going to start with phosphorus and chlorine. Okay, let's start with phosphorus. Now, phosphorus, we have 1 on this side and we have 1 here. So that's balanced. And here we have 5 chlorines. And this side from HCl, we only have 1 chlorine. So we need to change this side also to 5 chlorine so it can match with this side. So what we're going to do, I'm going to put a 5 in front of HCl. So now I have 5 chlorines and 5 chlorines, so the chlorines are fine. Now, because I changed the coefficient here, it means this 5 also goes to the hydrogen, isn't it? So now let's move on to hydrogen. So I have 5 hydrogens here, and this side I have 3 hydrogens. So altogether, 5 plus 3 gives me 8 hydrogens. So on the product side, I have 8 hydrogens, and on the reactant side, can you see from H2O, I only have 2 hydrogens. So I need to change this side also into 8. Now, I have to put a coefficient in front of here. So when I multiply it by 2, it must give me 8. So what if you put it by 2 will give you 8? It will be a 4. So 4 times 2 will give me 8 hydrogens. So now I have 8 hydrogen on this side, 8 hydrogen on this side. So the hydrogens are fine. Now the last thing we have to do is oxygen. So let's look at this side. Here we have 4. Because I put this coefficient here, it means it applies to oxygen also. So here I have 4 oxygens. Here I also have 4 oxygens. So automatically it balanced. The oxygens balanced, the hydrogens, phosphorus and chlorine balanced automatically. Now the last example we're going to do, this one only applies to grade 10. So grade 9s, please ignore example 9. This is not for you. Okay. Right, now if we're looking at this equation, this one looks very complicated, isn't it? Because it kind of is. Now what we're going to do is, we have carbons, we have oxygens, we have hydrogens, but we're going to start with carbon because remember in the rules, we leave hydrogen and oxygen for last. So let's start with carbon. On this side we have 3 carbons. On this side we have 1 carbon. So this side I also have to make it a 3. So what am I going to do? I'm going to put a 3 in front of this carbon here. Okay, so now I have 3 carbons here, 3 carbons here. Now let's move on to hydrogen. Now look at the hydrogens and see how spread out they are. If you're looking at the product side, can you see you only have H2O? So the only hydrogen is by the H2O. But if you're looking at the reactant side, can you see you have 5 hydrogens here? Plus you have another hydrogen here, which means you need to add up all of them because you can't just take one, you have to take all. Right, so we're going to say we have 5 here plus 1 here, and that will give you 6 hydrogens. Right, so on this side we have 6 hydrogens, this side we have 2. So we need to make this also a 6. So it's easy. Whatever you put here, you have to multiply it by 2, and that must give you 6. So if you put a 3 here, 3 times 2 will give you 6 hydrogens. So both have 6 hydrogens now, so the hydrogens are fine. Now let's move on to the oxygens. Okay, now we need to go to the oxygens, and it might get a bit complicated, so just pay attention. Right, just take it slow, one step at a time. Okay, so now let's look at the oxygens. Let's start on this side here. Here we have 1, 2 oxygens, and this side we have 2, so altogether we have 4 oxygens. Right, so let me write that there, 4 oxygens. Right, now on the product side we have 3 times 2, which is 6 oxygens, plus we have the 3 from here, because here you put a coefficient, so it became 3. So you have 6 plus 3, which gives you 9 oxygens. Now we have 9 oxygens here, here we have 4, and we need to change something here to also make it 9 oxygens. So there's 9 oxygens on both sides. Now if you look on this side here, can you see that oxygens are in 2 places? You have it here in this compound, which is a very complicated compound, and then you have it alone here, and here it's easier to change because it's alone. Now if I want to make this 9 oxygens also on this side, if I change a coefficient in front of this compound here, it means everything is going to change. The carbons are going to change, the hydrogens are going to change, everything is going to change, which is very complicated, and we don't want to do that. So if I change oxygen here, or if I change the coefficient here, it means only oxygen will change because you only have oxygen. So instead of making things complicated, we're going to go for this oxygen, which is alone, and we're going to change the coefficient only with this oxygen. Now what you need to do is you are going to take this 9 oxygens which you have on this side, and you are going to minus the oxygens that you have in this compound, which is not the one you want to change. So only the oxygens you have here, you're going to minus it. And here you can see you have 1 oxygen, 2 oxygens. So you're going to minus 2 oxygens. So you're going to say 9 minus 2, and that will give you 7. Right, now what you're going to do is you're going to take this 7, and you're going to make that 7 the coefficient of oxygen. Okay, now if I put a 7 here, can I see that if I say 7 times 2, that's going to give me 14, isn't it? And we want it to be 9 oxygens, not 14. So I need to get rid of this 2 somehow. And remember what we said, we cannot change subscripts. So what I'm going to do is something you have never seen before, okay? So I'm going to take the 7 and I'm going to divide it by 2. So now I'm dealing with a fraction. Can you see that, guys? A fraction in equations, right? It's possible. Okay, so I have 7 divided by 2. Now you know from maths, if you say 7 divided by 2 times 2, the 2's cancel out. So basically I'll be left only with 7 oxygens, because this 2 is going to cancel out with that 2. Even though you're still going to have it there, it's going to cancel it out. So it means now I only have 7 oxygens. So now if I have 7 oxygens here plus this 2 here, that will give me 9 oxygens. And on this side I know I have 6 plus 3, which is 9. So it is completely balanced. But can you see what I had to do? I had to use a fraction, which is something you don't normally see. Now how did we get that fraction? Let's just go through it again. We take the side which has the most oxygens, right? Then we go to the other side and we minus the oxygens in the other compound, which has other stuff like carbon and hydrogen. So you're going to say that 9 minus that 2 you have here, which will give you 7. Then you're going to take that 7 and put it in front of the oxygen which is alone and divide it by 2. So that 2's will cancel out. Okay. Now Normally in equations we don't like to have fractions because it's not really very nice. So what you do is, to get rid of fractions, we're going to multiply the entire compound by 2, because if we multiply 7 divided by 2 times 2, the 2 will cancel out and we'll just be left with 7. Now in a formula, it's just like in maths, whatever you do on the right hand side, you do on the left hand side. So if we multiply this by 2 to get rid of this 2, we must multiply everything by 2, the entire equation, the left hand side and the right hand side. So we're going to multiply everything by 2. So this side is going to become a 2, right? If I multiply this by 2, this will automatically cancel out. If I multiply this by 2, it will become 3 times 2, which will give you 6. And if I multiply this by 2, 3 times 2 will also give you 6. So at the end, you will be having 2C3H5COOH plus 7 oxygen, giving you 6 carbon dioxide plus 6 waters. And this is basically the most complicated type of balancing equations you will get. So if you can do this, you will be amazing.